Hello there. In this lecture, we will continue to learn about exponents, but this is actually roots or radicals. They are basically the same thing as exponents, but just in a different form. Let's write an equation that 5 to the second power is 25, right? Because 5 times 5 equals 25, and this 2 will indicate how many times we're taking that 5. Now, when it comes to radicals or roots, it basically asks you, what number do you need to multiply by itself to get to the number under the radical? I will show you. This is square root because it has number 2. So square root of 25, it means, translated into other terms, is what number do you need to multiply by itself twice to get to the number inside of the radical, to get to 25. And that number is 5. You see how this is related? Makes sense? Because 5 to the second power is 25. When you take a square root of 25, you're getting 5. They're inverses of each other. What about if we have 2 to the power of 5? Is 2 to the power of 5 the same as 5 to the power of 2? No. Listen, this is not multiplication the way you've learned that before. These are exponents. They work different ways. This means you are multiplying 2 by itself 5 times. 2 times 2 times 2 times 2 times 2 equals 32. What if you were to take fifth root of 32? You will get 2. This basically asks you, what number do you need to multiply by itself 5 times to get to 32? And that number is 2. One very important rule to note. If you do not see a number by the root like 5 or 2, that number is actually 2. Just like a with no power is the same as a to the first power. Same here. If you do not have a number here, the number is actually 2. You're taking a square root. For example, this means you're taking a square root of 4. So what number do you need to multiply by itself twice to get to 4? That number is 2. Another rule or property. Whenever you see a radical, you can rewrite it as the power. Whatever number you have here, right? 2. Number doesn't exist. There is 2. You can write it as a fraction. I'll show you what I mean. That is going to be a to the power of 1/2. If you see a number to a power of a fraction, you're actually going to take a root. And the number that's on the bottom, it will tell you what number do you need to multiply by itself this many times. How many times? This many times. This, okay? Makes sense? Okay. I will show you another way that you can write it down and memorize it. If you have c root of some number that is raised to a power, we can rewrite it as a to the power of b over c. I'll give you an example. Do not worry, the theory is very boring, but look, once you understand what is happening, you can easily read this. This is just like a hint for you, in case you're like, oh, wait, I forgot a little bit. Let me check back. And you see, you have it. I have fifth root of 2 to the third power. I can use this little formula, little property, and rewrite it as 2 to the third power over 5. Does it make sense? That's just a little property. We're just starting to learn roots and radicals. They're very annoying, I'm not gonna lie, and so many people, including myself, come up with their own rules. They just see the root and they're like, oh wait, I can actually add it. No, you can't. Oh wait, I can actually do this. Oh no, not gonna happen. Okay, I think we've learned enough for now. Let's just do some examples. In this example, I have cube root of 8. What does it mean? It asks you, what number do you need to multiply by itself 3 times to get to 8? That number is 2. Listen, I memorized it because I've dealt with numbers so many times, but do not get frustrated if you do not know it right away. It takes time. It takes years. It's fine. You're gonna use your calculator to figure that out. It's not like a guessing game. Okay, so what number do you need to multiply by itself 3 times to get to 8? That number is 2. So I'll show you. Because 8 can be factored out as 2 times 2 times 2. 3 times, same number. How many times? 3. 3 and 2, 3. Okay, so we're gonna remove 3, remove 2 of these, and remove the radical. Okay, and we're left just with 2. Fairly simple? I think so. Oh, also, one last thing before I forget. This basically means if you take b root of a raised to the b power, your powers are going to divide. You remember how I showed you before? And when you divide them, you're just going to get 1. So whatever number is inside of the radical, just remove all your powers. For example, here you have square root of 5 squared. You have square root squared. These two will go in the numerator and this two goes into the denominator, and they just cancel each other out. Just 2 divided by 2 is going to be 1, and you will be left with just 5. This is basically the same thing, because we can rewrite 25 as 5 squared. Listen, do not worry about it. I remember when my teachers were telling me this, or when I was watching videos, they were saying like so quickly, they were like, okay, this number is this number is this. Like, look, I haven't dealt with numbers for so long. I do not know immediately that you can take a square root of that number. I do not know immediately that this is the property. I do not know immediately like how to factor it. Like, I have to sit down and think about it for a little bit. So do not feel the pressure. Let's take a square root of 16. What number do you need to multiply by itself twice to get to 16? That is 4 times 4. What I mean, that number is 4. But 16 can be factored into 4 and 4. So 4 times 4, and you have this square root, right? If no number is indicated here, the number is 2. So you just remove it, and you're left with 4. All right, let's keep going. What about square root of 49? What number do you need to multiply by itself twice to get to 49? That is 7. This is your multiplication table. What is a cube root of 1000? What number do you need to multiply by itself 3 times to get to 1000? That is going to be 10. Listen, I know it right away because I know it. I've done it so many times. I've did so many examples that I know right away that number is going to be 10, right? I have 3 zeros, so 10, 10, 10. Okay, and I'm just going to remove everything. So a cube root of 1000 is going to be 10. But look, if you were to take square root of 1000, that is not going to be 10, because 10 times 10 is 100. So you cannot take, I guess you can take a square root of 1000, but that is not going to be a whole number. This is where we start to learn irrational numbers. Do not worry about that for now. I'm just talking too much. What about taking square root of 24? What number do you need to multiply by itself twice to get to 24? Let's factor number 24. 24 factors into 6 and 4, but we can also factor 6 and 4. So 6 factors into 3 and 2, and 4 factors into 2 and 2. So you're left with 3 multiplied by 2 multiplied by 2 multiplied by 2. What number repeats twice? That is 2. So therefore, we're going to take one of these 2 out, but one is going to be crossed. You're going to have 2 multiplied by square root of 3 times 2. And to get the precisest, the most precise, yeah, I don't think there is such a word as precisest. To get the most precise number, you're just going to be left with 2 multiplied by square root of 6. Do not worry about this for now. Like, do not get so frustrated. I'm just exposing you to some harder concept, but it's okay. We're going to take step by step. Let's just think a little bit of our squared numbers. What will be our squared numbers? So 1 multiplied by 1 is going to be 1. How about 2? 2 times 2 is going to be 4. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81, and 10 times 10 is 100. Look, you can take square root of these numbers with no problem. I simply memorize them, but I only memorize them because I saw them so many times. So with no issues, I can take a square root of 4. With no issues, I can take square root of 36. No issues, I can take square root of 64. Because I know the square numbers, they give me no issues whenever I'm taking a square root. Cube numbers, I only know 4. No, what am I saying? Cube numbers, I only know 8 because 2 times 2 times 2 is 8. Oh, and 27 because 3 times 3 times 3 is going to be 27. And then 4 times 4 is going to be 16. 16 times 16, I do not know that. Also here, I know 144. No, 121 because that is 11. 144 is for 12. And 169 for 13. I do not know the rest. It's none of my business, it's the business of my calculator. Let's practice rewriting roots into exponents. Square root of 5 cubed. When we rewrite it, we get 5 to the power of 3 over 2. Do not worry, you don't have to evaluate it right now. I would probably just use calculator to do that, and you're not going to get exact number. So we're just practicing rewriting it. What if you have 4th root of 16 to the power of 5? How are we going to rewrite it? We will rewrite it as 16 to the power of 5 over 2. I hope this is starting to make just a little bit more sense. Why I'm teaching you this is because in our next lecture, we're going to combine what you've learned, the fraction, how to convert the radical into a fraction power, and we will apply what we've learned before, exponent properties. So for example, if you have this, multiply by some other number with a whole power, or divided by, or whatever. And let's do our last example. I have 2 to the power of 8 and square root of that. What is going to happen? I'm going to divide, right? 8 by 2. And what number is that? That will be 2 to the 4th power. And what is 2 to the 4th power? So 2 times 2 is going to be 4, times 2 is going to be 8, times 2 is going to be 16. I hope this is starting to make just a little bit more sense. This is just theory, introductory. We will do more examples later and we'll start to make so much more sense. All right? Thank you for watching. Like, subscribe, comment, and I'll see you in the next video. Bye-bye.